Hello everybody, my name is Vladimir and I'll be showing my assignment for the functional restriction and composition. So here in the exercise 32, what we're trying to prove is that P composed with Q restricted to D star is not equal to Q restricted to D star composed by P, and which we can see here. And yeah, so to do so, I'll be first explaining what P and Q are, and then showing their visual differences in a graph. So to begin, I'll be explaining what P is, and to do so, thankfully, we have example 233 that show us what the unit disk and well, first we have to understand what unit disk is, which is all the X and Y values inside that are part of R2, where the addition of the squares is smaller than 1. So that what would be representing it's all the values inside the circle, and then we have D star, which removes the center. So it's all the values inside the unit circle, the unit disk, sorry, uh, which are not 0 and that are smaller than 1. Here, the circle having a radius of 1. So then we have S1, which is kind of similar. It's the values x and y inside of the R2 domain, where the addition of the squares it's equal to 1. So it would be all the values around the circle. So that would be the unit circle. So all the values that are like the square is the length of the addition of the square is the length of the radius of the circle. So the definition of P would be going from a value inside of the circle or the unit disk and being thrown or projected into S1, which is the unit circle. So here we have an example. X1 is here, and then it's being projected into the circumference of the circle. So that's P. And then for Q, we have a way shorter explanation. So it's kind of similar, like a two-dimension vector that's going to a two-dimension vector, and it's where it's x and y are the values, and the Q function, what it does, it just throws the y value into 0, so it projects the coordinates of the Cartesian point into the y axis. So that's what it's playing here. In geometrical is called the projection onto the y axis. So if it would be like in here, I show like a little explanation with the same point. So here, if it would be like here's a positive value, it would be going down. If it would be negative, it would be going up. So yeah, so here is my design to explain that. And to explain like the difference between the two functions, here we have this that it's first is throwing it to the circle, and then the other one is going down or up. I'll be using the same point, and here I can show you what the difference are between the two compositions. So here we have P composed with Q restricted to this R, and first will be, since the definition of the composition is to start with the second function, first we'll be throwing the point onto the y-axis, so the y will become x0, and then we'll be projecting the value onto the closest value, like to the on the circle, on the circle, on the disk circle. Is it the disk circle? Sorry, on the unit circle. My bad. So yeah, so here we project it onto the y value, and then we project it into the unit circle. So that's P composed by with Q restricted to this star, and here we have Q restricted to this star composed with P. So similarly to the beginning, we just project the value into the circle and the unit circle, and then we'll be projecting the value that's formed from that onto the y-axis. So here the x here would be staying and the y would be 0. So like we can see, just give me a second. From what we can see, it's very different one from the other, but and yeah, and here we can like it's visually obvious, but here like the y value would go to 0. Here if we say like x, like here at the end, the value that we'll be having at the end would be something like 1 0, but here the value that we'll be having at the end is smaller than 1 0 because we project it from here. So we could say something like 3/4 something like that, so we can see that it's not the same. Okay, so thank you very much, and that was my explanation. Hope it was not too long, and thank you very much. You have a wonderful day.